Welcome, viewers. Today we will be looking at the expression y is equals to e raised to power x, and subsequently we will be finding the differentiation of this expression. So we have an expression e raised to the power of x, and that is simply given as equals to 1 plus x over 1 factorial plus x squared over 2 factorial plus x raised to the power 3 over 3 factorial plus x raised to the power 4 divided by 4 factorial plus continuously x raised to the power 5 over 5 factorial, and so on and so forth. The value e is called the Euler's number, that is EULER, and that value of e is approximately equals to 2.718. So if you do a trial and say x is equals to 1 in that above equation, and then you substitute on the right hand side and the left hand side for x is equals to 1, you have e is equals to 1 plus 1 over 1 factorial plus 1 squared over 2 factorial plus 1 raised to the power 3 over 3 factorial plus 1 raised to the power 4 over 4 factorial. Plus, as you begin to increase to the right, and the value begins to get smaller. So when you add everything up, you tend to get e raised to the power 1, which is e, and then you get a value of about 2.718. But that's not really the objective of this video. The objective of this video is to be able to differentiate e raised to the power of x. But what we will be doing now is to simplify this further by simplifying the denominators. The denominators are where we have the factorials. So this expression above can now be rewritten as seen below. So what we have now is e raised to the power of x is equals to 1 plus x over 1 plus x squared over 2 plus x raised to the power 3 over 6 plus x raised to the power 4 over 24 plus we continue like that for the values of x from minus infinity to infinity, meaning this holds for all values of x. Now, if we look clearly, what we simply did was to simplify. 1 factorial is the same as 1, and that's why we have this. 2 factorial is simply going backwards, multiply by the next whole number. So what you have is 2 times 1, and that's why you have it as 2. Now this 3 factorial will simply be 3 times 2 and times 1. So 3 times 2 is 6, 6 times 1 is 6, and that's why we have this value. 4 factorial will not be different. It will be following the same pattern. 4 factorial is simply 4 times 3 times 2 times 1. And 4 times 3 times 2 times 1 is 24. So that's what we simply have done, is to make the expression simplified. Now we will be going into the differentiation of this expression with respect to x, and thus this connotation here. So we're differentiating with respect to x, e raised to the power of x. So what we simply do is to differentiate the values of e raised to the power x one after the other. Now let's look at this first term here, which is 1. If we differentiate 1, when you differentiate a constant, it is equals to 0, and that's why we have this value here. When we are differentiating x, what we have is 1. So what we have is x, and you know x is raised to the power of 1. Remember, when you are differentiating, remember multiply and minus. Now what are we multiplying? We're multiplying the power of 1. This power here is 1, so you multiply it by x, so you say 1 multiplied by x, and then you minus. So the same 1, you just subtract 1 from it. So what you have now is 1 times x raised to the power of 0, and x raised to the power of 0 is the same as 1. So 1 times 1 is 1, and that's how we got the value 1 here. Now the next expression is x squared over 2. So that's equivalent to saying x squared times half. So leave the half and let's concentrate on the x squared. So remember we said multiply and minus. So what are we multiplying? We're multiplying the power. So 2 times x is 2x, and then the 2 there, the power 2, we subtract 1. So 2 minus 1 is 1. So that's why we still have 2x. Remember, the half still remains. We don't touch it. Now let's look at the next component above in trying to differentiate. We have x raised to the power 3 over 6. So it's like saying x raised to the power 3 times 1 over 6. So let's leave that 1 over 6 and then let's concentrate on the x raised to the power of 3. Remember we said multiply and minus. So multiply 3 by x, you have your 3x, and then subtract 1 from 3, you have 2. So that gives us the expression 3x squared. And then we still have our 1 over 6 here. We move to the next component. We have x raised to the power of 4 divided by 24 is the same as x raised to the power of 4 times 1 over 24. So let's differentiate x raised to the power of 4. Remember we said multiply and minus. So multiply 4 by x, you have your 4x, and then remember to minus. And then minus 1 from 4, you have 3. So that's why we have 4x raised to the power of 3, and our 1 over 24 is still here. So we have simply differentiated, and let's see what we have when we simplify further. So the 0 here is knocked off, so we don't talk to it anymore, it's disappeared. We have 1 over 1, which is 1. In this expression, we have 2 here, 1, and then 2 here, 1. So you're left with x over 1. And then in this expression, 3 here, 1, and then 3 here, 2. So we have x squared divided by 2. And then in this expression, we say 4 here, 1, 4 in 24, 6. So we're left with this expression. So you have x raised to the power 3 divided by 6. So that's what you have. So our simplification of the differential of e raised to the power x is equals to 1 plus x over 1 plus x squared over 2 plus x raised to the power 3 over 6 plus, and so on and so forth. What we will simply do now is to look at the denominators, and we will be expressing them in form of factorial. So we'll start with 1, and then after that we move to 2, and then of course we move to 6. Remember that 1 is simply equals to 1 factorial. 2 is equals to 2 times 1, which is equals to 2 factorial. And 6, which is the other denominator there, is equals to 3 times 2 times 1, which is equals to 3 factorial. So we will be expressing the above differentiation, and then of course the denominators in form of factorial. So that gives us the differential of e raised to the power of x is equals to 1 plus x divided by 1 factorial plus x squared over 2 factorial plus x raised to the power 3 over 3 factorial plus and so on and so forth. So that's what we have for this expression. So just rewriting it once again, when we differentiated e raised to the power x, what we have is 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial. Now remember at the beginning we said that e raised to the power of x is 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial. If you look above, you'll see that when we differentiate e raised to the power of x, we got the same value as the function e raised to the power x. So the top value when we differentiated is the same as the original expression of e raised to the power of x. So that tells you and I that if y is e raised to the power x, our differential, which is dy dx, is also e raised to the power of x. Thank you for watching this video. Kindly subscribe if you have gained any value. Kindly like and share.